So hi students, I am here, Dr. Hilal Ahmed. Today we are going to discuss about very important chapter that is very much concerned with us and our society, that is the electricity. Okay, so we will try to understand about electric current and its circuit, electric potential and potential difference, the circuit diagram, how we can complete a current, so Ohm's law and other factors on which this electricity and its associates depend. Okay, so what is the need for it? Actually, we know that in our recent times everything is dependent on electricity only. Okay, so life is now has become impossible without electricity. You just think and for a moment that if there is no light in our house, what are all the things you cannot do? Okay, we have to charge our devices, and we need light, and we need to cook, and we need more and more things to be done. Even the vehicles which are riding on the roads, and the aeroplane that is flying in the air, and whatever machinery you can see, that is fully controlled and it is dependent on the electricity. Okay, that is why it has become now, as a student, it has become now very important for us to understand the origin, its origin, okay, where this electricity comes from, and what are the different characteristics. Okay, characteristics and how we can utilize it. Okay, sorry, mistake. Okay, utilization of this electricity. Okay, that we need to discuss in this chapter. So before we start, let us see what is the origin of this electricity, how electricity is produced, and what are the cause which makes the electricity to be the electricity, okay, to be a current. The first thing is we should know about charge. This charge, which is denoted by small q, charge is actually the characteristic unit of any matter, because of which any matter we can say it is positive or it is negative. Okay, so we can say that it is the characteristic unit of the matter by means of which matter experiences the electric force. Okay, the electric force that any matter which experiences, so because of which the matter can be called as electrically positive or electrically negative, that is because of the charge in that matter. Okay, so it is a characteristic unit because of which the matter experiences the electric force. So since it is a quantity, so it is having its unit. So how we can how much of charge is there? It is in the kgs, kilograms, or in meters, or it is seconds, it is in the hours. No, it is having its own SI unit, that is International System of Unit for Charge is what? It is coulomb. The international unit for charge is coulomb. Okay, and this coulomb is represented by capital C. So how much charge a matter is having? We can say a matter is having 1 coulomb of charge, 2 coulombs of charge, 3 coulombs of charge. Okay, so how much charge is there? That is we can say how many coulombs of charge is there. So we can say, we know that each and every matter is having the charge in it, we can say that if the charge is there, so what are the things in the matter we have actually? We know that if each and everything is made up of elements, and in the elements we have electrons, okay, and then we have protons. So protons, for example, we can say that any element is there. In this element we had the electrons which are present in its outermost shell. Inside it is the protons. So these electrons, they are moving, they are in always in some current, they are in some motion, okay. So when we remove some electrons from this, what will happen? Here we will be having net positive charge here, okay. We will be having positive charge because we removed the left charge. For example, when we talk about carbon, in carbon we have how many electrons? We have 4 electrons present in the outermost shell, okay, and in inner shell we have 2 electrons. So it means outside there are 6 electrons, but inside there are 6 protons which are positively charged, so these matters actually. So when we remove one electron, it means one positive charge is there because one extra proton will be there. When we remove 2 electrons, okay, we can say 2 positive, okay, like that. So in this way we can understand that we want to know that one column of charge means what? One column of charge means the net charge. One column net charge is equivalent to the charge contained, which nearly it has been calculated by the experts, okay. They know that it is about 6 into 10 to the power 18 electrons. So when we say one column of charge, it means this much of electrons are there present, okay. Now how many columns of charge we want? So Q, this total number of total charge of a matter can be given by Ne, okay. Ne, it is given by the Ne. N is the number of electrons, and E is what? E is the electrons, number of electrons. So for example, if we say that Q equal to 1 column, then, and we know that E charge of electron is, this is very important, we should note down this, the charge of each electron is actually, electron is negatively charged, so it is having 1.6 into 10 to the power minus 19 column of charge is present in one electron, okay. So we want to know in one column how many electrons are present. So we can say that we can use this formula. According to this formula, number of electrons will be equal to Q divided by E, so which is equal to 1 divided by 1.6 into 10 to the power minus 19, which finally comes equal, here we can write it as this also, 100 by 16 into 10 to the power 18. So this we can denote as 6.2 into 10 to the power 18. So finally we got now number of electrons in one column of charge is equal to 6 into 10 to the power 18 electrons. This can be a separate question where we have to verify that the number of electrons in one column of charge equal to 6 point, it was here 1.6. No, it is actually 6 into, yeah, it is correct only, 6 6.2 not. We finally, if we calculate this, this will come here. It will come here 6 into 10 to the power 10 to the power 18 electrons. So number of electrons is equal to 6 into 10 to the power 18 electrons in one this. So finally we got that the number of electrons in one coulomb of charge is equal to 6 into 10 to the power 18. Okay, this is all about we came to know how we can calculate this. So for this numericals will be there which the students have to solve. Okay, there are a lot of numericals, you can go by any way. If you have been given the columns, how many coulombs of electricity, then you have to solve it accordingly. Okay, so sorry for this break. So by any way we can calculate any of these things. So since here we don't have time, so that I can give you some examples for this, let us move, because our topic is actually electricity. We want to know something about current. We are approaching to what do we mean by current and how we can calculate the current using these formulas. Now let us see current. Current. Students, when we are talking about current, as we in our general ways we talk about current. Current is actually the rate of flow of net charge is called current. Rate of flow of net charge. So if we have any metal, okay, if we have any metal, in that metal the current is flowing, we can say. Actually what is flowing inside? It is the charge that is flowing, that is moving. We can say electrons are moving in that metal. Then in 1 second or in a given time, how much charge will flow from one point to other point? Okay, that is called current. That is called current. So the rate of flow of net charge in any circuit is called when we say the rate of, means it denotes time. So it is denoted by, current is denoted by capital I, and we can give the formula for this. Capital I equal to Q divided by T, rate of flow of charge per unit of time. So how much charge is flowing in how much time? Okay, so this is very important. How much charge is flowing in how much time? Okay, so electric current can be defined thus now as the amount of charge flowing through a unit cross section in per second. So if we talk about one electric current, the amount of charge flowing through a unit cross section. Unit cross section means if this is also one, this is also one, this is also one, it means the electric current is that is flowing. Hello, अस्सलाम कह रहा बस क्लास चला वैसे दबस यह आवर क्लास चलान वैस 1 मिनट पे ओड गंट खंड ফিলহাল আসবো, বিকেশ যাইবাও ঠিক আসবে। হ্যাঁ। Okay, so we came now. If I want to know 1 unit of current, what does it mean? 1 unit of current means it is defined as the amount of charge that can be flowing through a cross section, unit cross section, in 1 second. In 1 second, because here all we're taking 1. So the SI unit of current is SI unit of current is ampere. And this ampere is denoted by capital A. Okay, now let us define 1 ampere means what. 1 ampere means it is defined as 1 coulomb of charge flowing per second. So in 1 second, 1 full coulomb of charge which is flowing in 1 second, we can call it as 1 ampere. So 1 ampere is equal to 1 coulomb of current charge flowing in 1 second. You understand? So this can be called as 1 ampere current. Okay, in an electric circuit, so circuit means when we have a complete flow, where the flow of charge is complete from one point. This is suppose the battery, where we give the flow of charge, this positive, negative, so it is complete. So in an electric circuit, while the current is flowing in the opposite direction, flow of current will be mentioned in the opposite direction of the electron, okay, charge. For example, if we discuss here, suppose the electrons they have left from here. The direction of electrons is like this. For example, from here they have to reach this destination, okay, because it's the flow of charge only. So the charge is flowing in this direction, then the direction of current will be opposite to it. So this is the direction of current. So the direction of current is opposite. It is what? Is opposite to direction of charge in a circuit. Circuit means any cross section of metal where this current is flowing and it is complete. Okay, so this current is called conventional current. It flows from the positive terminal of the battery. So this current will always, the direction of the current will be from the positive terminal of the battery or to the negative terminal of the battery. So the small quantity of current is expressed in, we have milliampere also. So 1 milliampere, which is equal to 10 to the power minus 3 ampere. Milli means 1000, 1 by 1000. Okay, so then we have the microampere also. 1 microampere is equal to 10 to the power minus 6 ampere. Milliampere, microampere. Okay, so milliampere and microampere. Now this was all about this. So now we have how we can come to know, how we can measure how much current has been passed. So in this circuit, how much current has been passed. So scientists, they have designed one instrument. That instrument is called ammeter. Okay, ammeter. This ammeter is used, it is an instrument used to measure the electric current in a circuit. So it is always connected in series. We have to be very important. It is always, ammeter is always connected in series. in a circuit. So what is series? This we will come to know in the proceeding part of our lecture. That is where we can say that sometimes we are keeping the thing in the series, that is in the same way how it sometimes we are keeping it in the parallel. Okay, that we will come to know what is series and what is parallel in the. But whenever we want to calculate the current, the ammeter will be connected in series with the with our that circuit. Okay, so it has a low resistance. Practically, ideally, ammeter it should have the resistance should be actually 0 in an ammeter. So resistance also will come to know. Resistance means the hindrance, that is the blockage of current. Sometimes because metal will be different, when we try to pass the electrons, sometimes the electrons, it becomes very tough for electrons to move very fast. Okay, something that stops them, okay, makes their makes a barrier for them, but finally the current is, so that is the, we call it as resistance. Okay, so this resistance also will come to know in the future this lecture. Now let us see what is electric circuit. In an electricity circuit, it is a closed it is a closed path along which the current will flow. Electric circuit is nothing, it's a closed path along which the current will flow. For example, I will try to make here one electric circuit. In an electric circuit, we have some important points. For example, this is the device, like let it be the bulb. Okay, this is our bulb here. That bulb, we want the current to pass through this bulb. Then there will be a structure called key here. Okay, now here you can see that it is our complete circuit. Okay, what is the direction of this? Suppose this is positive, suppose not, it is the positive terminal of the battery and this is the negative terminal of the battery. What will be the direction of electrons and what will charge and what will be the direction of current? This arrow will be, because from positive to the negative. Okay, so this will be the direction of current, but the direction of charge will be opposite to it. So electrons will start moving opposite to it. This we should know. This is ammeter. A means ammeter, which is in series with this device in the circuit, and this is bulb. Okay, this bulb is connected here. This is the flow of current, and this is key, because in every circuit we should have on and off key. Okay, so the arrow here shows the current of electric. In this circuit, we can say ammeter is connected in series. Okay, ammeter is connected in series. The electrons can only flow when there is a difference in the potential. So this is all about the electric circuit, which I tried to draw for you people. It is a closed complete path of the current flow. That is where the electrons, or we can say the charge is flowing, the current is flowing. Here everything should be connected. There should be no disconnection. Whenever there is anything we have cut here, this will not allow the current to flow. So key should be on. This is in on. Okay, if we don't have this dot here, so it will be called it is off. Circuit is not complete, so the bulb will not glow. This is all about this. Now we have something here, some important points here. We want to know what do we mean by electric potential difference. So electric potential difference. Before we see what is electric potential difference, we should know that the electrons in a circuit from one point to other point, suppose these are the electrons, they have to flow from one point to the other point. Why they will go from here to here? Why they will go? There should be some sucking power here. Something should pull them towards this direction. This is point B and this is point A in a rod, or we can say it is a metallic rod. Why the electrons will flow from point A to the point B? It means that the electrons here either they are in more quantity, and here it is less quantity, or we can say here it is more negative charge. That more negative charge, it has to balance, so it has to flow from A to the B so as to get the balance. That is why it is flowed. For example, we can take the water, this example of water also. When the water is flowing in a tube, for example, this is a tube, okay, why water will flow from here? If I put the water here, okay, I will use one small funnel, and in this, using this funnel, I will insert the water in this tube. Why the water will flow from this direction, point A to point B? Yes, something push and pull is there. Because of what? Because of which the water flows from point A to the point, it reaches the point B. It is only possible when there is a high pressure at one side and low pressure at the, here we have low pressure and here we have high pressure. Same here, at point A we have high pressure of electrons, at point B we have low pressure of electrons. So you understand? So that is why it will move from the high pressure to the low pressure. In case of electric current, the flow of charge is made possible due to chemical action. Okay, the chemical action using a cell that generates the potential difference across terminals. So we have a small cell. In that cell, you know, we are all aware about this is the positive terminal, this is the negative terminal of the cell. So we want the current, okay, sorry, I will make it this direction. We want the current should come from one terminal of this cell to the other. This is negative, this is the flow of, in between we want to keep some device. This device can be anything, but finally the current has to come back. For example, it is a small bulb. The current has to come back and it has to move to the other terminal of the battery. Okay, so actually what makes it possible? There is some chemical change. Because of that chemical change, what happens actually inside the cell, which takes place, which makes the more charge present in this terminal. We have more electrons here. Those electrons, they have to flow from this negative to the positive. Okay, it means the chemical reaction here, there is the need of electrons, and here we have excess number of electrons. Some chemical reaction is taking place at this terminal, because of which the electrons are there. So when we open the gate for these electrons, how to open the gate? Because electrons will only move when it is a metal that connects them, okay, from high pressure to the low pressure. So here there is more pressure of electrons. They start moving. When they start moving, they reach here. Here it is a need of electrons. So some chemical reaction is taking place here. And the chemical action within the cell, which generates the potential, that is called potential difference. Here we will not use the pressure, we will use the potential difference. Okay, potential difference, which creates the potential difference across these two terminals of the cell, because of which the current will start flow. Now what is potential difference? In the terminology we can say it is defined. It is now defined. The potential difference is defined as the work done. So as the work done in carrying a unit of charge. Unit means anything. Suppose one charge, 1 charge, 10 charges, 100 charges. Unit of charge from one point okay, to the other point in a circuit, in an electric circuit. Okay, so some work needs to be done to make the charge to flow from one point to the other point. So this work which needs to be done, it is an energy which needs to be spent so that this charge should come from one terminal to the other terminal. It is defined as capital V. Okay, potential difference is defined as capital V. So capital V is equal to work done per unit charge, W by Q, work done per unit charge, net charge. So here we have V is the potential difference, okay, then W here means work done, so work to be needed, and Q equal to net charge. So this is the formula for electric potential difference. The SI unit of, since it is a quantity now, we should know the international system of units. So how we can calculate this? What is the unit for this? The SI unit for potential difference is volt, V-O-L-T, S volts. So it is defined by V, okay. So it was named after one of the, it is inventor or discoverer, we can say Alessandro Volta. This was the name given, this name has been given in credit to the, it is discoverer, okay. So 1 volt, now as we saw there, 1 unit of current means what? Here also we can see 1 volt means what? 1 volt can be defined as, we know that the work, the unit of work is joule. The unit of work is joule, and the unit of charge is coulomb. We know that, okay. So we can say that when 1 joule of work, so 1 volt means when 1 joule of work is done in carrying one coulomb of charge from one point to the another point of a current carrying conductor. That time we can say that the potential difference is equal to 1 volt. So 1 joule of work is required to carry one coulomb of charge from from point A to point B, okay, in an electric circuit. At that time we can say the potential difference is of that circuit is equal to 1 volt. I have my students an understanding. So we can say that 1 volt is equal to 1 joule of work done to carry one coulomb of charge from one point to the other point. So this was all about potential difference, okay. So now in a circuit, if we want to calculate how much potential difference has been, so we want to measure the potential difference, we are using an instrument. That instrument is called voltmeter. Meter means the measuring machine, okay. Instrument, volt means volt only, okay. So voltmeter is an instrument used to measure the difference between and respected this potential difference, and is mostly represented by the symbol, like we can have like symbol like this, okay. This is the symbol given in a current, in an electric circuit. But this voltmeter is always connected in parallel. parallel in an electric circuit, unlike the ammeter, which is always in series. Here we have the voltmeter, it is connecting in parallel to the points between which the potential difference needs to be measured. Okay, so it has high resistance. What it has? It has high resistance. So that we will see in the next we can see in next session of our this. So till now we have finished about what is current and what is the origin of current and potential difference, because now full chapter will move around these V and I. V and I is current and V is potential difference, and we will come to know about one more term, that is the resistance. Okay, resistance here, let me little bit give a hint about resistance. Suppose the water has to move from point A to the point B, from high pressure to the low pressure. Here the thing is, if I keep small sand particles here and here, or I start pressing here, I will press the point here, and this pressing this pipe, okay, what will happen overall? It will just hinder, or it will just make a difference in the flow of this water from one point to other point by using, because so same is the case in metals also. Since we have different types of metal, we say iron is there, aluminum is there, and so on. So lot of, we have full list of metals, not only metals, alloys, like composites, which are good conductor of electricity, which let the electricity to pass through them, but their structure is different. Inside structure is different, means they will be having different resistance. Resistance means what is the ability of that metal to let the electrons or charge to flow through it fast or fast or slow. So because the structure is different in different metals, what will happen actually, based on the structure of that metal or the composite of that metal, there will be the flow of the charge in that metal will be high or it will be low. When the flow is high or low, we say it means resistance. How much is resistance in that metal? How much it is having ability to let the electrons or charge to flow fast or to flow very slow in that. So that we call it as resistance. This also we are going to see in our next session. So my suggestion for the students is now to know about all the symbols. When we have a circuit, in that circuit we are having some symbols, like for cell, like this is the symbol for cell. Let me finish here. We have some few minutes here. So how, if we want to denote the cell is mostly denoted like this. This is positive and this is negative. This is the symbol for cell. Then what about battery? Okay, so this is actually, we are revising here what we have been, our teachers have taught us in the primary section itself. So okay, this is the negative terminal, this is the positive terminal of the battery. So this is the battery. Then key open and key switch. How we can define? Key can be defined by two ways. One way is this is off and this is on now, or we can say key will be like this is off and this is on. Okay, then we have that is closed or it is open circuit. So joint wire, if we want to show, if we have this, so it means the wire is jointed here. Then bulb is denoted by the symbol like this. Okay, so this is the bulb. Then ammeter is given by the symbol like this, capital A with positive and negative. Okay, then voltmeter, it is denoted by the symbol V on both the sides having positive and negative here. Okay, then finally which we talked about resistance. Resistance is denoted by the symbol like this. Okay, this was all about. Then we have one more, that is the rheostat or variable resistance, that we will discuss. This is not our level to know that. So these were all the symbols which are used in a circuit. When we draw a circuit, we will be having these like things. This is the wire, okay, common wire. This is the wire. Okay, so in the wire, when we are making a circuit, we will show these symbols. That time the student should know what is this actually denoting. Okay, so students, with this I think we have finished our today's topic. Okay, so I request my students to be in touch with our next topics, next sessions which we are going to talk, okay, which we are going to deliver here. So with this, let us finish our today's session. So I hope you understood, and I request all the students to be in touch with your textbook, that is NCERT textbook or your state book textbook, where you can have more information and with more examples and diagrams in it. So you have to see them, you have to try to draw those diagrams to get more experience in your subject. Thank you.